Hello everyone! My name is Svetlana Isakova and I'm a developer advocate in Kotlin. Today we are going to talk about new language features in the Kotlin 1.4 release. This release was mainly focused on quality and performance. There are many tooling improvements, and as you know, we are actively working on the new compiler. One of the important parts of the new compiler, the new type inference algorithm, we are going to discuss a bit today. We are adding a bunch of new features to the language that we hope you are going to like and use. Some of them were expected by the community for quite a while, like SAM conversions. Others, like trailing commas, are small but really useful. Let's start with SAM conversions for Kotlin interfaces. SAM is an abbreviation for a single abstract method. If you define an interface with only one abstract method, that is called SAM interface. You often want to pass a lambda or callable reference when an object of SAM interface is expected. The ability of doing that is called SAM conversion. Starting from the very first Kotlin version, it works this way with Java interface. If you have a method runAction that takes the action interface as a parameter, in Kotlin you can pass a lambda instead. If you try to convert this Java code to Kotlin, however, you'll get an error. An official recommendation says, please try to use function types instead. Conceptually, you should have taken a function type as a parameter, not an interface. We had a request to fix that, which was created 5 years ago. It says that, okay, we understand that SAM conversion only works for Java interfaces, that is by design, that everyone should use function types instead, but that is inconvenient. This issue got loads of votes and comments, and we've often had requests to fix it. In Kotlin 1.4, we're introducing the concept of functional interfaces to address this. Be aware that we're introducing a new combination of keywords, fun interface. You need to add the fun keyword before an interface to make SAM conversions possible for it. Then you can pass a lambda instead of this interface. But this trick only works with functional interfaces. You may be asking, why have we introduced this special extra keyword and not simply allowed using all interfaces with one method by default for SAM conversions? A part of Kotlin philosophy is that we want your intentions to be explicit. If you have an interface that is intended to be used for SAM conversions, to pass lambdas instead, make it explicit. Imagine you define an interface with one method and someone uses it for SAM conversion, but it wasn't your intention. Now you are adding another method, and the usages no longer compile. With the functional interface, you see the error immediately when you try to add a new method. But most importantly, you decided to make it a fun interface, and you can't change that and break usages accidentally. Now it's time to finally get rid of Java interfaces in your code preserved only for SAM conversions. Now I want to discuss another topic related to the philosophy of being explicit. We are introducing an explicit mode for library authors. The Kotlin Style Guide contains special recommendations for library authors, an additional set of rules to help to ensure API stability. The first recommendation is to specify member visibility explicitly. That prevents accidentally exposing an internal or private declaration as a part of the public API. Imagine you define a function in your library, and it's obvious from its name that it's a private function and you don't want to expose it to external code. However, you forgot to add a private modifier, and now it's a part of the public API, and it's impossible to revert it without breaking someone's code. If you follow the rule that you always specify visibility, you are protected from such mistakes. You can't forget a modifier and expose something unintentionally. Another recommendation is to specify function return types and property types explicitly. For a similar reason, to prevent breaking the code by accident. For example, you define the getAnswer function and allow the Kotlin compiler to infer its type, its string. But maybe then you decide to change a minor thing in the implementation, to replace the string 42 with the number 42. And with this change, you break the user code. The users assume that the type is string, but now it's any. And you only learn about this breaking change from the complaints of the users later on. For libraries, this is unacceptable. Nothing should break unexpectedly without proper warnings and migration support. To prevent such problems, we recommend always specifying return and property types. And that is exactly what explicit API mode is doing. Before 1.4, these recommendations were only written in the style guide. We assumed that it's a good idea to follow them, but now both these recommendations can be enforced by the compiler. You compile your code in explicit API mode, and the compiler forces you to specify visibility and return types for these functions. You can decide what's more useful to you when these rules are violated, to get errors or warnings. You can see different settings for Kotlin and Groovy Gradle scripts. You can also specify it as a compiler option. Explicit API mode is mostly intended for library authors. However, if you find it useful for your project, for example for some of the modules, please use this functionality. Now let's move on to the next topic, which is extremely useful. Following many other languages, Kotlin now supports trailing commas. Imagine you see a list of elements in the code, and you want to swap the last two elements. You try to use IntelliJ IDEA functionality to swap the lines, but you get a compiler error because the last line doesn't have a comma. Trailing comma solves this. You can now put a comma after the last element in the list. Then swapping works fine and the code compiles. When you type the argument, you don't need to decide straight away whether it's the last one or whether you'll need more. If you don't like how it looks, you don't have to use it, it's optional. We don't force you to start using trailing commas everywhere. You can also put a trailing comma after the last parameter of a function or class declaration. Note, however, that if you want to refactor a function or a class declaration, we recommend not swapping the lines, but rather using the change signature automatic refactoring provided by IntelliJ IDEA on Android Studio. When you use change signature, all the usages are correctly modified for you. You are protected from forgetting to swap the actual arguments, especially if the types are the same. So please use automatic refactorings. Kotlin 1.3 forbids using break or continue inside when. If you try it, you see that the compiler suggests using labels. A workaround exists. You can label the outer loop and then append this label to break or continue. But that's inconvenient. We wanted to reserve break and continue inside when, probably for some logic related to the when expression. But it turned out that usage with relation to outer loop is expected by everyone, so now these usages are allowed. You can use continue or break inside a when expression. It's then bound to the outer loop. The next topic I want to cover is mixing named and positional arguments. In Kotlin, you can specify names for the arguments, and that's sometimes really helpful. If the argument is the number or another basic type, or the expression type is not obvious, specify the name. In some cases, however, it's kind of redundant. In this case, you see that it's a color and you don't need to add the name. Kotlin 1.3 doesn't allow you to mix named and positional arguments. Formally, you can mix them, but only add named arguments after all positional ones. And in some cases, it's not enough. So we fixed it. In Kotlin 1.4, if you use every argument in the correct position, you can give names only to those arguments that needed them for clarification. The next topic I want to discuss a bit is the new type inference algorithm. You already know that we are rewriting the Kotlin compiler, and many of you have already used the new type inference algorithm that was available for you to try. It's a more powerful algorithm rewritten from scratch that fixes more than 300 existing issues. It supports functional interfaces, infers type in more use cases, and brings benefits to more complicated scenarios. I will show you a couple of cases to illustrate that. Mostly, you'll notice by yourself that some of the code that didn't compile before now compiles. You can avoid extra type costs, and so on. Let's look at the first example. Here, we define a map. In Kotlin 1.3, the compiler doesn't infer the type of the lambda argument. But if you look closely at this code, this type becomes kind of obvious for you. String is key in this map, and the type of lambda is a function type that takes a nullable string as an argument and returns Boolean. That means that the type of the lambda argument is a nullable string. If it is obvious for you, then why is it not obvious for the compiler? It wasn't supported, but now it works. The Kotlin compiler infers types correctly in this and similar more complicated scenarios. Another case when Kotlin starts to infer types in tricky cases is when the last expression in the lambda is smart cast. In this example, the string value is smart cast. The Kotlin compiler understands that it's not null. However, before that, the type of result was a nullable string. Now it's an ordinary string. Also, you can use callable references in more complicated cases. You can use reference to a function with a default argument value as of different types. For instance, you see this function foo that takes an integer parameter and returns string. And you use it as a function reference that takes int and returns string. But you see here, the foo function defines a 0 default value for the parameter. Now we can also interpret this function as a function that takes no arguments and returns string. In Kotlin 1.4, you can pass such a function reference to the apply function that expects a function without parameters. Then the Kotlin compiler correctly uses the default value. You pass a function reference, and the Kotlin compiler understands that you wanted to use 0 as the default value. That's really helpful in many scenarios. There are many other similar examples when the type inference algorithm infers more powerful types. I've just picked several to illustrate the concept that this algorithm is smarter now. The next feature that I want to cover is unified exception type for null checks. It's not a new language feature that you can use somehow in your code. However, I want to mention it and explain it so that you won't be surprised if you see another exception type for nullability issues. Different operations in Kotlin, such as 2 exclamation marks, typecast, platform type, expression null checks, parameter type checks, they all related to nullability. Currently, they throw different types of exceptions, like Kotlin null pointer exception or in some cases illegal state exception, with helpful messages. And Kotlin 1.4 replaces all these types with the regular null pointer exception. Note that only the type of the exception changes. Everything else remains the same. All the exceptions are thrown in all the same places they were thrown before. No new exceptions are added, no old exceptions are removed. Only the type has changed. For instance, in Kotlin 1.3, after additional nullability checks, you could get an illegal state exception with a message like, "This expression must not be null." In Kotlin 1.4, it automatically becomes null pointer exception, but with the same message as before. You shouldn't normally get these exceptions in correctly working applications, so the behavior of your program shouldn't change. Why did we make this change? It makes possible future optimizations. Right now, we don't do any optimizations. It's something to be implemented in the future by the Kotlin compiler or by the Android 8 optimizer. This optimization is especially important for Android. The goal of this optimization is to decrease the number of checks in the cases when they are repetitive. It turns out that very often the checks are generated on several levels, and they all check whether the same expression is not null. When you check the same condition several times, it's possible to merge the checks and to check it only once instead. If the type of the exception is the same, it's null pointer exception everywhere, that can be done because it doesn't change the program behavior. Of course, after this optimization, some messages can be lost, but that's the price to pay for making this optimization and for eliminating some of the null checks. Note that it is something to be done in the future, but I wanted to emphasize that we've changed the exception types. I want to talk about generating default methods in interfaces. It's still experimental, and we've had support for it before, but we've made some changes and I want to highlight what exactly has changed. In Kotlin, from the very first version, you've been able to define default methods in interfaces. This even works with the Java 6 target. But as you know, only starting from the Java 8 target, methods with implementations in interfaces are supported in the JVM bytecode. Kotlin has a special trick to make it work for older Java targets. It generates an additional static class inside this interface that contains the implementation as a static method. Then, when you extend this interface, the Kotlin compiler automatically inserts the Aviridian method that only delegates to that static method defined in an additional class. And that works for Java 6. But for Java 8, when you already have the JVM support for default methods, most probably you don't want this overhead of an additional default impulse class. Starting with Kotlin 1.2, we provided an option not to generate default impulse implementation, but rather use the JVM support for this method. You could use a special option, set JVM default to enable, and annotate each method of an interface with JVM default annotation. Then, no default impulse class is generated. The default methods are used in the bytecode. In fact, you could use one of the two modes for the Java 8 target. The first one, which I've shown you, generates only default methods. Alternatively, you could instruct the Kotlin compiler to generate both default methods and default impulse classes. You might have needed that for compatibility reasons. The second mode is often used by library authors that evolve their library and shouldn't break the code that depends on their library. You had to annotate each method with this JVM default annotation. Now we are changing this approach a bit, and we don't require you to annotate each method with annotation, because it's kind of verbose. You need only to specify one of the two modes when you compile the code, but no additional annotation is needed. In Kotlin 1.4, there are two new modes for generating default methods in interfaces for the JVM 8 target. The old ones are deprecated. The new modes are very similar to the previous ones. There is a mode for generating only default methods and another mode for generating both default methods and default impulse classes for compatibility reasons. The only difference is that the JVM default annotation is no longer required. You can compile the code in JVM default all mode, and then no default impulse classes are generated under the hood, and you don't need to use the previous JVM default annotation. Currently, these two modes are in an experimental state, but they will be used by default in future major Kotlin versions. First, the compatibility mode, then the mode that generates only default methods. You can read more about generating default methods in interfaces in the Kotlin blog. It explains the topic in more detail, including an additional JVM default without compatibility annotation, which I haven't mentioned. Check the documentation page What's New in Kotlin 1.4. It contains many details about the features in the release, including the topics that I've covered in this talk. Thank you for your attention and have a nice Kotlin!